Hello everyone. Today we're going to be doing a SageMaker Edge Manager demonstration. As part of that demonstration, we're going to quickly cover how to link your IoT device with the AWS cloud. The procedure is well documented in the SageMaker Edge Manager Getting Started guide, so we'll just briefly cover the points and show roughly what it looks like to have it set up. To start, you'll need an AWS account, as well as a IAM role for the SageMaker operations that we'll be doing in today's demonstration. An example of that would be SageMaker Neo compilation of models or using the Edge Manager to package the model artifacts. We'll need another IAM role for the IoT device to assume. In this particular case, we're going to be using a Jetson Nano. And if we look at the actual IAM policies and roles, we'll see that the SageMaker execution role that we'll use today is the standard execution role that will get created if you just generically make a studio instance. It has the Amazon SageMaker full access policy attached, which is quite a permissive policy, but there's only a few functionalities we'll really need for today's demonstration, such as the Neo compilation jobs. The other IAM role that we created is in this case, something we named SageMaker IoT. It has these four policies attached, in particular, IoT things registration, IoT logging, IoT rule actions, and lastly, the policy for SageMaker Edge Manager device fleet policy. As part of this role's trust relationship, we also add a trusted entity of credentials.iot.amazon for the authentication process. Within the IoT console, we can see that we do have a thing registered as our home Jetson device. We generated certificates to use in order to authenticate the device and have downloaded them. And lastly, we have registered a edge device known as Jetson Nano and attached it to a device fleet within SageMaker Edge Manager known as Home Jetson Fleet. We can see that this particular device fleet will assume the IAM role of SageMaker IoT that we had previously. Now that our IoT device can be connected to the cloud, it's time to prepare our machine learning model that we plan to serve at the edge. In order to do this, there will be two steps, the first of which is to use Neo to compile the model to run quickly in a lightweight runtime. The advantage of this is that you don't need to install a full-featured machine learning framework such as TensorFlow or PyTorch on your device, but instead get to run in the very lightweight Edge Manager runtime. To do this, we're going to create a compilation job from the SageMaker console. There is API access to be able to do all of these features that we're going to see today as well, but for the demo, we'll use the console since it shows well. I'm going to specify my job name. It's a TensorFlow UNet model saved in a Keras H5 format. Again, we're going to use that SageMaker execution rule in order to launch this particular job. The location of the model artifact needs to be an S3 location. It needs to be packaged in a tar format, which is what you'll get if you train your models in SageMaker. But it's worth noting that you can also bring your own models to this step and just package them appropriately. We'll specify a data input configuration since this compiled model works on static inputs, and that's how the compilation and fusing of ops process works. Specify the framework as Keras, but there's a number of different options, including XGBoost, TensorFlow, TF-Lite, PyTorch, MXNet, etc. For our target, we're going to select the criteria needed for the particular Jetson Nano that I am running. That is a Linux operating system, ARM64 CPU. It does have a NVIDIA accelerator, so we'll select that. And the particular version of Jetpack I'm running has a TensorRT version of 7.1.3. It's running CUDA 10.2 and has the GPU capability of SM53. The output location will be an S3 bucket, so I'll just specify that here. and then I'll submit the job. You can see the job will start, and when it's complete, you'll get a compiled model in the S3 bucket that you specified. So if I go to UNet compiled, we'll see the UNet Linux ARM64 NVIDIA file that we just created. If I copy that S3 URI, the location of this model artifact, I can then do the final step in preparing the model, which is creating an edge packaging job. So if I go to Edge Manager in the SageMaker console, go to Edge Packaging Jobs, create a packaging job. I can specify the name, which in this case we'll call demo UNet edge package. The model will be UNet Keras demo. For a model version, we'll specify it as 1.0. This is a key point in the demonstration here because a nice feature of Edge Manager is the ability to load more than one model at once. So you can actually have different versions of the same model loaded on your Edge Manager agent and make separate calls to each loaded model in a very quick fashion. We'll use that execution role again to create this job. And lastly, we'll click Next. We'll need a compilation job name to specify here, which we can get from the compilation step that we just took. So you'll see here, tf-unet h5 demo run is what we just ran. I'll put that in as the compilation job that we're going to build our packaging job from. And lastly, you'll need an S3 bucket to throw it into. So I'll use the same bucket name here just for brevity. And we'll submit. For the next part of this demonstration, we're going to actually run the Edge Manager agent on our IoT device. So to do that, I will follow the documentation and download the current version of the Edge Manager agent. It comes as a tar file, so I'll extract that. And then we'll also gather the certificates that we created from registering the IoT device on AWS Cloud, as well as some root certificates that it's mentioned in the documentation. I will put those certificates in the Edge agent file, and I will rename this as agent. Next, I will copy this over to my IoT device. I'm just going to use a SCP GUI here, but we'll just copy it over, and then we'll access it through the console. Okay, so now that it's here, we can see that the certificates that we brought over are available. We'll load up the console from an SSH window, and we'll see that we're now on the Jetson device. Within the agent directory, you will need to place a file that is the configuration file for what will happen with this particular agent. So we'll see that I will identify the edge device unique identifier as we did when we registered this through the SageMaker console. I will specify the device fleet name. There is a number of different capabilities around data capture. So one of the key capabilities of SageMaker Edge Manager is that it enables you to actually capture tensors both from the input side, so capturing data that's going to your model at the edge, as well as the predictions of your model as it runs. There's capability to kind of spill that to disk if there is network connectivity issues, and so that's what these different parameters are. You'll specify the region, AWS region that you're going to interact with. You'll need to specify that certificate path that we just saw. And we will also need to specify a few more of the certs, and as well as the IoT credential endpoint, which is documented on the website, how to get a hold of your individual IoT cred. So once we have that configuration file on the device, we can simply run our Edge Manager agent by calling towards that particular config file. So we're going to be within the agent directory calling the binary SageMaker Edge agent binary, pointing to the config file, and then actually specifying the Unix socket that we will accept data in on. So as that runs, you can see that the IT credentials are given, and we'll let this run in the background as we interact with our model. Lastly, we're going to cover what could be considered the most important part of this demonstration, and that's actually interacting with a running Edge Manager agent. So to do this, we'll look first at what comes in that Edge Manager tar file that we originally extracted. You can see within the API folder, there is an agent.proto file. What this file is it's a schema of how you can interact with a SageMaker Edge agent. The proto file is language agnostic, so you take this file, you compile it with whatever programming language you prefer to use, and what you'll get is a machine-generated output that you can use in order to interact with the agent. In this particular case, we'll see that there's two Python files. I used Python, proto-C, it's pip installable, and what you'll get is these classes that let you interact with the agent, things like loading models, unloading models, predicting, capturing data, very standard APIs that you would expect. After compiling that proto file on our Jetson device, we'll now see that the stubs, the auto-generated modules, have been created and are available on our device. Also want to call attention to some models that I've copied over to the device. These are the Edge Manager package jobs that we performed earlier. I've just simply taken them from S3 and copied them over to our device. Want to point out that in a separate terminal here on the device, we are running the agent actively. In production, perhaps you'd want to do a detached mode or a daemon, but in this situation, I'm just going to run two terminals. So the agent's running in this one, and on this terminal is where we'll interact with it. So to do that interaction, what we'll need is a Python script, because that is the programming language that I'm using. You can see here that we import those two auto-generated modules, which are the APIs to interact with our Edge Manager agent. We have some simple helper utilities here, ways to list the models that are available on the Edge agent, ways to load new models and unload them. As we previously mentioned, you can actually load several models into the agent and then predict by specifying which model you want a given tensor to be inferred with. There's utilities for creating the agent tensors. We have the predict class, which we'll look at shortly, but the meat of the code is down here in the main section. We can see earlier from our Edge Manager agent config file that we specified this Unix socket to pass data between. So you can see this will be our gRPC channel. We're going to specify our model path. This is the location of our model file on disk. We will simply load the model, and then we'll just generate some random data using NumPy in this situation here and pass it to our predict function. Our predict function does have some capabilities for leveraging, say, shared memory. We won't go into the details of that for this tutorial, but at a high level here, what we'll be doing is we'll be taking that NumPy tensor, ensuring that it's float32 as the model expects, and simply converting it to bytes. Next, we'll pass that to our CLI, that agent API, in order to run a prediction. We'll be running this in a loop just to get some timing data. And then at the end, what we're going to do is leverage the Edge Manager ability to capture data, whether those are input tensors or output tensors, and seamlessly upload those to S3 buckets for downstream consumption. It's as simple as a call to the agent capture data request. And now, in order to see this script in action, I will simply run that on the agent device. So I had a couple of prints in that script. The first one was just printing what the loaded models were. So here you can see we have a unit model, and you can see the input tensor name, that static shape that we specified actually during our Neo compilation job. And then lastly, I printed the output tensors. So these are our predicted mass tensors. As you can see, it's in NumPy format as expected. And this model runs quite fast on the Edge Manager device. Finally, we'll look at the captured data in our S3 bucket. So you can see here's the S3 bucket. This is the bucket that we specified when we launched the configuration file. We can see that it is in the prefix here under our home Jetson fleet. The actual captured data is partitioned by date, which is quite useful. And we can see here that the captured data includes both our input tensors and our output tensors, which you can leverage in downstream fashion, whether that would be retraining your model with newly captured data or just validating that your edge device is predicting as you expect. So this has been a demonstration of using SageMaker Edge Manager. We've shown how to compile models, how to package them up, how to run the agent on a device, and how to interact with it.